They will be covering sections 4.1 to 4.4.
First, moving on to section 4.1 on factors and time factorization.
We have some example problems here, and first one is 630 prime? And we can see that 630 is not prime because 630 has many factors as shown below with the factoring tree, including 63, 10, 9, 7, 2, 5, and 3.
Next, is 7 prime? 7 is obviously prime because the only other factor 7 has besides 7 itself is 1. Thus, 7 is a prime number.
Next, section 4.2 on greatest common factor. A common factor is a whole number that is a factor of 2 or more non-zero whole numbers. The greatest of the common factors is the greatest common factor, also known as the GCF.
And 2 or more numbers are relatively prime if their greatest common factor is 1.
Next, we have some example problems. So find the greatest common factor of the numbers.
Moving on to the first question. So 2 and 4's greatest common factor is obviously 2 because 2 is relatively prime and it's literally 2 or 1, and 4 is 4 or 2, so the answer is 2.
Next, we have 13 and 42. Because 13 is prime, the only factors that 13 has is 1 and 13. And because 42 is not divisible by 13, the greatest common factor here is 1.
Next, 42 and 35's GCF is 7 because 7 times 6 is 42 and 7 times 5 is 35, and thus it's 7.
Next, we have 24, 21, and 9. And the greatest common factor of these three numbers is 3 because 24 is divisible by 3 and 8, 21, 3 and 7, and 9, 3 and 3. And we can clearly see that 3 is a greatest common factor.
Next, moving on to section 4.3 on equivalent fractions. Equivalent fractions means to write equivalent fractions, you multiply or divide the numerator and denominator by the same non-zero number. An example is 1 over 3, which is equal to 1 times 2 divided by 3 times 2, which is 2 over 6, or simplified, 1 over 3.
Next, we have an example problem. Find an equivalent of the fraction. So the first one we have is 5 over 10, and this can be either half or 10 over 20. We got half because we divided both the numerator and denominator by 5, and then we got 10 over 20 by multiplying the numerator and denominator by 2.
Next, 12 over 20 is equal to 3 over 5 if you divide 4 to the denominator and numerator, or it can be 24 over 40 if you multiply 2 to the denominator and numerator.
Next, we have 28 over 49. This can be either 4 over 7 or 56 over 98. We can get 4 over 7 by dividing the numerator and denominator by 7, and we can get 56 over 98 by multiplying the numerator and denominator by 2.
Lastly, 4 over 14 is equal to 2 over 7 if you divide 2 to the denominator and numerator. And it can also be 8 over 28 if you multiply 2 to both the denominator and numerator.
Next, we have simplifying a variable expression. So we have 10xy over 15y squared equals 2x over 3y. And 10xy over 15y squared equals 2x divided by 3y because we can divide by 5 for both the numerator and denominator to get 2 and 3, and then we can also divide the numerator and denominator by y to get 2x over 3y.
Next, 42r to the third power divided by 56 to the second power is 6r over 8 or 3r4 divided by 4 because when you divide 7 to 42 and 56, you get 6 and 8. Moreover, r to the third power divided by r to the second power gives a final of number r on the numerator, so 6r over 8 or 3r over 9 is the answer.
3r over
9.
49t squared over 7t cubed is equal to 7 over t. And we can get this answer by dividing by 7 for both the numerator and denominator, and then also dividing by t squared to get 7 over t.
Next, moving on to the least common multiple. First, a multiple is when a whole number is the product of the number of any non-zero whole number.
Next, we have common multiple, which is a multiple that is shared by 2 or more numbers.
Next, we have LCM, which is the least of the common multiples of 2 or more numbers.
Next, we have the LCD, or the least common multiple of 2 or more fractions of the LCD's denominators, and LCD is also known as least common denominator.
Next, moving on to some example problems. So first, find the LCM of the numbers. First, 48 and 24. The least common multiple is 48 because 48 is obviously 48 itself, but 24 times 2 gives 48, which is the smallest number that is common from the factors of the two numbers.
And then next we have 6 and 8, and the LCM is 24 because 6 times 4 is 24, and 8 times 3 is 24, and nothing less than 24 can be gotten by multiplying any number to both 6 and 8.
Next, moving on to finding the LCM of the following equations. First, 9x y to the second power divided by 15x squared and y gives the final answer of 35x squared y squared, because the least common multiple of 9 and 15 is 45, as 9 times 5 is 45 and 15 times 3 is 45, and there is no smaller number that is common from the multiple of the numbers. And since there's already x on top, it has to be x squared, and same for y, so we get 45x squared y squared.
Next we have 14ab and 21bc, and the least common multiple of 14 and 21 are 42, because 21 times 2 equals 42, and 3 times 14 equals 42, and because we have a already, we need to put a into the least common multiple, so 42a, and then because we also have bc, we can include bc also in the least common multiple. The little caret symbol there is a mistake. Thank you.
Thank you.
Great job, you did it. See you in the next video on sections 4.4 and 4.6 to 4.6. Bye.